two projects. In this video, we are going to explain about the project that is improving the classification performance of asphalt cracks with earthquake with a new feature selection algorithm. Before getting into the execution, first let us understand what is the project about. Imagine a scenario where a major earthquake hits a region and one of the first things that people need is medical supplies and food. The highways are the primary routes for delivering this aid, but because of the earthquake, many of the roads are severely damaged. For example, in a rural area, a large crack forms across a major highway, blocking any vehicle from passing through. Emergency teams are now faced with the challenge of finding alternative routes, but these are neither too far or also damaged. The delay in getting these supplies to the victims worsens the situation, causing more suffering and the loss of life. Let's take another real world example. During 2010, Haiti earthquake, where roads were so damaged that aid had to be delivered on foot or by air, which significantly delayed the process. Many roads were blocked by rubbles or cracks, which made it difficult for the trucks carrying essential supplies to reach the affected areas. In such situations, full surveys of the roads couldn't be done immediately. So, in such situations, full surveys of the roads couldn't be done immediately as many routes were inaccessible. If these roads had been regularly maintained or assessed for vulnerabilities before the earthquake, the impact on transportation could have been minimized and the aid could have reached the victims much faster. This highlights the importance for proactive highway maintenance to ensure that roads remain passable during after disasters. So, the traditional methods of road inspection and maintenance are often time consuming, labor intensive, they are costly, and also they are particularly in the aftermath of large scale damage like that caused by an earthquake. These methods typically rely on specialized personnel who must physically inspect the roads. While this approach may be effective under normal circumstances, it becomes a bottleneck during widespread infrastructure damage as the sheer scale of damage overwhelms the ability of human resources to assess and repair the roads quickly. So, in this case of major disaster, waiting for manual inspections and reports can delay crucial repairs, hindering relief efforts and slowing down the delivery of aid. This process This process are not fast enough to meet the urgent needs of disaster stricken areas, and resources are often wasted on less critical repairs while more urgent issues are left unaddressed. This inefficiency underscores the need for automated system that can rapidly assess the severity of asphalt cracks and determine which repairs are the most urgent. Such a system would streamline the process, optimize this use of resources, and ensure that repair efforts are focused where they are needed most, ultimately improving the response time and effectiveness of disaster relief operations. So, the system that we have proposed is designed to automatically predict the condition of highway roads in areas affected by earthquakes, helping ensures that aid reaches victims without unnecessary delays. So, the core of this system is deep learning models, that is VGG16, which is used for extracting the important features. It is a pre-trained model. So, this is to detect extract features from images of asphalt cracks. After these features are extracted, we use a special algorithm called combined combined meta heuristic optimization relief algorithm, that is CMOR, to enhance the features. So this algorithm combines 10 different algorithms, that is ASO, EO, PSO, etc. So to improve the feature selection process and ensure that only the most relevant features are kept for the further analysis. Once the features are optimized, we apply relief algorithm. So we will be applying relief algorithm to select the best ones for the classification. And then six different machine learning algorithms that are support vector machine, KNN, that is K nearest neighbor, MNN, that is medium neural network, decision tree, LDA, naive Bayes are used to categorize the cracks into two different classes. One is major and minor. So this approach, I mean, among these algorithms, medium neural network, that is MNN algorithm, performs the best, delivering the most accurate predictions. So this approach allows the system to quickly and accurately assess road conditions, helping authorities to prioritize repairs where they are most urgently needed, ensuring faster and more effective disaster response. So this is the proposed system. Moving on to the extension to further improve the performance, this project incorporates the voting classifier. It's an ensemble model to boost the system's accuracy. So this model combines multiple algorithms which are random forest, naive based latent dirichlet analysis, that is LDA and XGBoost, and then uses a voting mechanism to pick the one that performs the best. This way, we are leveraging the strengths of each algorithm to make more accurate predictions overall. And we have built front end using Flash framework, which is designed for user testing. This means users can interact with the system directly and provide feedback. The front end includes secure authentication to make sure that only authorized users can access it, ensuring the system security. This setup allows for a more dynamic and interactive evaluation of the system's performance, making it easier to identify areas for improvement or adjustments in the practicality. Moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So first, let us understand what is the first step. So this step involves importing the essential libraries such as TensorFlow, Keras, NumPy, OpenCV, and the others required for handling the images. And then comes the data preparation. So here we load the images from the dataset, which contains two major classes, that is minor and major, and all images are resized to 32 by 32 pixels to standardize input size for the model. And then all the pixel values of the images are normalized to a range between 0 and 1, ensuring the model can process the data more efficiently. Then comes data splitting part. So the data set is split into two subsets. One is training set and the other one is testing set. 80% of the data is assigned to training and the remaining 20% is assigned for testing. Training is used to train the model and testing is used to evaluate the model performance on unseen data. Coming to feature extraction. So here the VGG16 pre-trained model is used to extract the meaningful features from the images. This helps to reduce the dimensionality and capture the important patterns for the classification. Coming to feature selection, so the CMOR, that is Combined Meta Heuristic Optimization Relief algorithm, is applied to optimize the features by selecting the most relevant ones, which improves the model performance by removing unnecessary data. Coming to model building, so here we will be initializing all the models that we will be training, that is support vector machine, MNN, decision tree, etc. And that initiated model will be trained on the training data to understand the patterns for predicting the nature, that is for predicting the cracks of the road, whether it is major or minor. And then all those models will be evaluated using accuracy, precision, recall, and FN score, and they will be compared through the graphs. Coming to the part of front end, so a user-friendly front end is developed using Flask, which includes features such as user registration, login, and integration with SQLite database for storing the user data. And in the front end, users they will be able to give the images in the front end for detecting the road, whether it is major or minor crack. And that image will be pre-processed at the back end. It will be fed with the trained model. Finally, outcome will be displayed through the front end of the application. So this is how we have implemented the project. Moving on to the algorithms used. So these are the algorithms used in this project. This is the extension model and this is the proposed model. Moving on to the requirements, to implement this project, we need basic requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework Flask, backend framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. So let us open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So in the dataset folder, we have the dataset used in this project. So here we have images in both the folders, that is major and minor. Let's open the images which are in major. Let's open it. So these are the images of the highway road where the cracks are major. So these cracks are major. These images we will be training the model to predict the cracks on road. So here in this minor folder, we have the images of the highway where the cracks are very minor. So these are the images. Let's get back. Get back. And here in this model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files, which will be loaded into the project code during runtime of the application. And here in the static folder, it consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And coming to the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in this folder, we have the test cases. So these are the test cases that we will be using in the front end for predicting the cracks. Get back. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook file. This is the Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So this is the notebook.ipynb file. And this is the signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open command prompt. It has been opened. Give the command cd, give the space, paste the copied path, and now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So this is the localhost and this is the port. Now we are supposed to copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get signed up first. Click on that and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. And here you're supposed to provide your username and the password. So I'm giving my credentials, which are my username and the password. Now click on login. So we have logged in successfully and we are redirected to prediction page of the project. Here you can see a choose file button, right? We need to click on that for uploading the test cases. So click on that. So these are the different test cases that are the images that we will be uploading now for predicting the crack on the road. So first let's upload this one. Click on open. It has been loaded. Now click on upload. So the given image, it will be pre-processed at the backend and then train model will be giving us a prediction. So this is the image that we have uploaded and here we got the prediction as major. So this is the highway road and here is the crack. So it has been predicted as major crack it is. Now let's try with the one more image. Click on choose file. Let's upload this one. Click on open and now upload. So here we got the prediction that it is a minor crack. So here it has been predicted as a minor crack. Now let's try uploading some more. Now let's upload this one and click on upload. So here we got the prediction as major crack has been predicted. So on the highway, there is a major crack predicted. Here you can see the prediction. Now let's check with some more. Click on choose file. Let us upload this one. Just wait for a while. Image is being pre-processed at the backend. So here the image has been predicted. Here we got the prediction that a major crack has been detected. Now let's check with the last image. Click on choose file. And now let's upload this image. Click on open and now upload it. So here we got the prediction that a minor crack has been predicted. So here minor crack is predicted. Now let's check with the graphs. Click on graph. So here the first graph which we have is the accuracy comparison graph. So this is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms trained for predicting the major or minor cracks. And this is the precision score comparison graph. This is the recall score comparison graph. This is the FN score. And that's all. Accuracy, precision, recall, and FN score are the metrics used to evaluate the models, that is classification models. Now click on sign out. In this way, just by uploading a highway road images to the system, then the system will classify whether there is a major crack or minor crack. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.